Hey guys, welcome to IC Chris. Today's video is going to be looking at momentum and impulse, and hopefully by the end of the video I can convince you the importance of wearing a seatbelt. So we'll look at some examples like that. But before we get into that, I just want to say thank you to all the subscribers. You guys are really helping out a lot. If you're not subscribed to the channel, please consider subscribing. We have just hit 100 subscribers, so I will be doing a live Q&A session within the coming weeks, probably near the holiday coming up for the schools. So yeah, get your questions ready and I'll give you the date in the next video. But without any further delay, let's get into today's video. Okay, let's start off by looking at momentum. Okay, so momentum is given as the product of your mass and your velocity. So if I start up here, momentum is given as the product of your mass and your velocity. So we represent momentum with a P. It's your mass times your velocity. Okay, so you can see it's the product of mass and velocity. Now note that momentum is a vector. Okay, so it's a vector quantity. Okay, therefore it needs direction. Okay, now let's just look at our SI units quickly. So our standard SI units for mass is kilograms. So P is going to equal to kilograms. Okay, and then velocity is measured in meters per second. Okay, so our SI units are then going to be kilograms per meter, or multiplied by meters divided by seconds. Okay, now momentum, as I've stated, is a vector quantity, so direction is key, so you have to pick which direction you're moving in before you start your question. Okay, now Jeremy Clarkson once stated that speed has never killed anyone, but suddenly becoming stationary, now that's what normally gets you. Okay, so let's see what he means by that. So I'm going to do this by a practical example. Okay, so let's consider traveling in a car. So let's say I'm traveling in a car. Okay, here's my car, and let's say we're doing about 80 kilometers an hour on the highway. Okay, so if we convert 80 kilometers to meters per second, we divide by 3.6. okay, which means I'm going to get 22.22 meters per second. Okay, that means because the car is traveling at that speed, I am also traveling at that speed. Okay, so now let's say you come to a sudden stop. So we're doing that speed and we come to a sudden stop. Let's say the car stops within 0.5 seconds. Okay, that means my initial velocity, okay, is 22.22 meters per second, and my final velocity is 0. Okay, now we are going to take as if acceleration is constant, therefore we can then use our equations of motion. So let's quickly find out what our acceleration is. Okay, so we can then use v final equals v initial plus a delta t. Okay, so v final is 0. My initial speed was 22.22 meters per second plus a times 0.5. Oh, sorry for the shakiness. Okay, so if I take this over, it becomes negative. I'm then going to be dividing by 0.5, which means I'm technically multiplying this by 2. So my acceleration is going to be negative 44.44 meters per second squared. Okay, so my acceleration is insanely high. Okay, now let's say we take my mass, so I'm 65 kilograms. Okay, so let's work out the force. Let's see what's happening if I come to a stop instantly. So the force which is going to be acting on me, okay, is then going to be my mass, so 65 kilograms, times my acceleration, which is negative 44.44. Okay, if you multiply that together, you're going to get a force of 2,889 newtons. Okay, that's quite high. That's how much force it's going to take to stop me if I'm moving at that speed, so 22.22 meters per second, That's how much force is going to be needed to stop me in 0.5 seconds. Okay, which is an enormous amount of force. To put that into perspective, to break a windscreen, so windscreen, you need 2,100 newtons of force. That means you've gone through the windscreen. The windscreen's not going to stop you. Okay, which means now let's see, what force do we need in order to stop ourselves, or what mass, what body of a certain mass do we need? So we have our force, which is 2889 newtons. Okay, now gravity, remember gravity is used to work out newtons of a mass. So let's see what mass we need. That's 9.8. Okay, so if I divide that out, we find that we need a mass of 295 kilograms. Okay, so the only way I will stop is if something of 295 kilograms is acting on me at the same time that I'm acting on it. Okay, Newton's third law. Okay, so this is why it is so important for you to wear a seatbelt. Okay, now let's just have a look at what our momentum is, since this is actually what we're dealing with here. So if we look at our momentum, we said that momentum is equal to my mass times my velocity. Okay, so my mass is 65 kilograms. My velocity, okay, is then 22.22. Okay, which means my final momentum is going to be, let's have a look here, it's going to be 1,444 kilograms per meter per second. That means for every second that's passing, I'm moving 1 meter and my mass is 1,444. So I've increased my mass by 22.2 times, okay, which is absolutely insane. So you can now go and figure out what happens if you're moving at 200 kilometers an hour on the highway. You can then work out meters per second, and you can see at what your momentum is going to be. Okay, but the other thing that we're going to be looking at is how do we relate momentum to force now without having to use equations of motion. Okay, so the nice thing is we can use what we call impulse. Okay, so impulse relates force to momentum. Okay, so let's go back to quickly Newton's second law. If we look at mass force equals mass times acceleration. Okay, but what is acceleration? Acceleration is just change in velocity over change in time. Okay, those dashes just indicate that these are vector quantities, sorry. So now I'm going to rewrite this as force equals mass times the change in velocity over the change in time. Okay, but what do we know about mass and velocity? Well, we know that mass times velocity equals to momentum. So if I take the change in velocity times my mass, I'm going to get the change in momentum. Okay, so therefore force is equal to the change in momentum over my change in time. Okay, remember those are vector quantities. So therefore we can relate the force that an object experiences when moving to its momentum in a period of time. Okay, and that's what we call impulse. The other way it can be written is this over here. Okay, so taking that same situation with me in the car, we said that we were moving at 22.22 meters per second. Our mass was 65 kilograms, and the time for us to that impulse took place, or when we came to a stop, so that period of time was 0.5 seconds. Okay, so now if we plug that into our equation here, we're going to have force is equal to the change in momentum. Okay, but remember when we're moving with the car and when we come to a stop, we go from our momentum with the car, and when we stopped we have no momentum. So our change in momentum is just going to be 65 times 22.22, and our time here is 0.5 seconds, which means if you plug that into your calculator, you'll get back out the exact same force on the other side, which was given as 2,889. 2,889 newtons. Okay, so that's how we can calculate impulse. Okay, let's just quickly look at the SI units for impulse. So we said that impulse was force, which is equivalent to my change in momentum over my change in time. Okay, so let's just look at the SI units for impulse. So impulse is just the change in momentum. So we're going to take our time across. It's delta T times force equals to delta P. Okay, now we can see here that time is measured in seconds, force is measured in newtons, and therefore my change in momentum, okay, is then equal to newtons per second. So let's see how that works. If I start with my change in momentum, momentum is kilograms times meters per second. Okay, because that's my velocity. So now I'm dealing with kilograms per meter per second. Okay, but how do I get to newtons? Remember, newtons is equal to kilograms per meter per second squared. Okay, so here I already have kilograms per kilograms times meters per second. Okay, so in order to get to this, I have to multiply this by 1 over t. Okay, so 1 over time in order to get here. Okay, so therefore we can see that the other way we can write the change in momentum or our impulse is then going to be newtons per second. Okay, if you want to work it back the other way, if we start with force over here, it's going to be kilograms per meter per second divided by seconds, which means we can rewrite that as kilograms per meter over seconds divided by seconds, which is then kilogram per meter per seconds times 1 over seconds, okay, which then gives you kilograms per meter per second squared, which equals newtons. Okay, so either way we get back to force. Okay, let's have a look at the following question. So we have a trolley that comes into contact with the spring on the wall, and after that the spring pushes back on the trolley and pushes the trolley off in opposite direction. Okay, so here we're moving with 6 meters per second, here we're moving with 3 meters per second. Okay, so I'm going to take right as positive and left as negative. Okay, so anything moving right will be positive, anything moving left will be negative. So question 1 says calculate the momentum before it hits the spring. Okay, so we're looking before here, just before it hits the spring. So we know that momentum is going to equal to our mass times our velocity. Okay, and we have everything, so therefore our mass is 3 kilograms and our velocity is plus 3, okay, it's moving to the right, meters per second. Okay, which means we then have 3 times 3 is 9 kilograms per meter, or times meters per second. Okay, not too bad there. Then it says calculate the change in momentum of the trolley. So it comes into contact and then the spring pushes it away. So now we need the change in momentum, but note that the mass is still the same before and after. Okay, so we can write the change in momentum is going to equal mass times the change in velocity. So mass is constant, so I'm only going to use it once. So I'm going to have my mass here, 3 kilograms. Okay, I'm going to have my change in velocity. Now remember, change in velocity means v final minus v initial. But note that my final velocity is negative because it's moving left. So I'm going to have minus 6 meters per second minus 3 meters per second. Okay, so now what we're going to have is we'll have 3 kilograms multiplied by minus 9 meters per second, and 3 times 9 is 9, 18, 27. So that's minus 27 meters or kilograms per meter per second times meters per second. Sorry, it's kilogram meter per second. Okay, now it says the average force acting on the block from the spring. Okay, so it's going to come into contact here. Okay, so here it's going to come into contact, and then the spring is going to push back with a certain force in order to increase my velocity. So let's have a look here. This is talking about impulse now. So we know that the force is equal to the change in my momentum over the change in time. Okay, so I've realized I haven't given a time yet. So let's say that's in 0.1 seconds. Okay, so now we're going to end up with a change in momentum, which we've already calculated up here. So minus 27. Okay, or we can take the magnitude because it's the average, so we don't have to incorporate the minus there. So 27 kilograms per meter, or times meters per second, okay, divided by the change in time, which is 0.1 seconds. 0.1 seconds. Okay, so if we plug that into our calculator, 27 divided by 0.1, we're going to get a force of 270 newtons. Okay, remember we're dividing by seconds, so therefore we times and flip, which means this becomes seconds squared, which gives us newtons. Now looking at the average acceleration. Okay, so we've just worked out what our force is. Now we know from Newton that my force is equal to my mass times my acceleration. Okay, so I have the force, that's 270 newtons. I have my mass, that's 3 kilograms. Okay, so I can work out my acceleration. So acceleration is then going to give me 270 divided by 3, which is 90 meters per second squared. Okay, so it's slowing down really quickly. Okay, so because we have acceleration and it's a vector, okay, the same with our force down here, sorry about that, you can incorporate the negative here, then we know that it's acting to the left. Okay, so sorry about that, you can incorporate the negative there. If you just take the absolute value of that, then you would have to write left. Okay, and same over here, this would then actually be minus 90 meters per second because we're moving left. But if you put the negative, you don't have to write left because the negative indicates direction. Okay, now it says the average rate of change of momentum in 2. Okay, so in 2 we calculate the rate of change. Now note that rate of change, okay, means something's changing with respect to time. So we normally write it as the change in something as time changes. Okay, later on in calculus you'll learn that this is called a derivative. Okay, so we want the change in momentum over the change in time. But what does that look like? That is just equivalent to my force, which we calculated down here. So we can see that the rate of change of momentum is just equal to my force, which is 270 newtons. Okay, I'm going to put the negative in, which means to the left. Okay, that's how we do this question.